Okay, this is problem 19-17. It's another adjusted present value problem. I say another one because I think I did one video on a adjusted present value problem earlier in this problem set for this chapter 19. But just to review what adjusted present value means, it's just a method of calculating the value of a project, or you could use it to calculate the value of an entire business, that separates out the sort of base cash flow without considering whether debt's used or not. In other words, what's the value of the project if it was financed with all equity, no debt at all. So you calculate that number first. Then, if you're considering including debt as part of the financing structure, you make a separate computation of, okay, are the tax shields, because interest in most countries is tax deductible, so it reduces your tax. So there is some benefit to using debt as opposed to equity, and you calculate that as a separate number and add the two together to get the total value of the project. And that's different than the weighted average cost of capital method, where the tax shields are considered in the computation of the discount rate. You take the cost of debt and then reduce it by the tax rate, and so that lowers the discount rate, which increases the value of the project, because you discount anything at a lower discount rate and the present value is greater. I sort of like this method. I think it's more the weighted average cost of capital method sort of blends everything together, so you can't sort of break out the two different components of the value, but others see different things. I'll say in advance, I'm not really sure what is meant by this part of the problem. So you may need to ask your professor about that. But let's just start with the basics. Let's get some of the assumptions here. It says all equity financing, cost of capital with all equity financing. So I'm going to call that R sub E. It's 10%. The project allows the firm to borrow at 7%. So I'll call that RD. For debt is equals 7%. Tax rate is 35%. And okay, that I think gives us our assumptions. So the cash flows, this is handy here. Well, it's implied, but the growth rate in cash flows is 0 because it says it's $9,500 a year into perpetuity. So, I mean, $95,000 a year cash inflow into perpetuity. So that implies no growth rate in the cash flow. So what's the value of this cash flow? Well, this is in perpetuity, so we can use the perpetuity growth model. First, we need to compute the cash flow after tax cash flow as if this was funded 100% with equity, no debt. So you take the $95,000 of cash inflow, subtract the tax on the full $9,500, which is $33,250, which gives you an after-tax all equity cash flow of $61,750. So after tax, all equity cash flow. Now, what's that worth in present value terms? Well, fortunately, with these assumptions, that's pretty easy. The normal perpetuity growth model is cash flow divided by R minus G. In this case, G 0, so it's just this number divided by 0.1, which is the same as multiplying by 10, of course, which gives us a value of this project of $617,000. Well, yeah, the gross value, not the net present value, because we haven't considered the initial investment. But the value of the project's cash flows are $617,000, assuming that's the present value after tax, all equity. Now you can see pretty quickly, since it said the investment requires $1 million, there's a upfront investment of $1 million, and the value of the cash flows after tax, discounted at this equity rate, is only $617,350. I mean $617,500. That this project has a negative net present value. So if we were going to finance this project with all equity, we'd just stop right here, because we'd say it's not worth it. This costs us $1 million up front. And so you could just, just to show that explicitly, would have a negative $382,500 net present value. Same after tax, all equity. So no go in that case. But in this situation of A, we assume that we're going to finance the project with $400,000 of debt, which means $600,000 of equity. And we're going to look at the tax benefit of that, because since tax is deductible, we've got $400,000 that we borrowed times 0.07%, the interest rate on the debt. So that gives us, let's see, $28,000 a year in interest expense. And that saves us 35% in taxes. So that gives us a tax shield of $9,800 forever. And so we can apply this same our discount rate, growth rate, and this, since everything's static, growth rate's also 0. So this gives us $98,000 of additional value related to the tax shield effect, which still doesn't make this project a positive return project. Now there's I believe this is the answer to A, but I'm going to caveat that with something to ask your professor about, and it's this number here. For B, I think what they may be getting at is that if the borrowing is floating, increased or decrease, and increase or reduce in proportion to the changes in the market value of this project, that you would discount the tax shields not at the equity discount rate, but at the actual rate on the debt, which, since that's lower than equity, that's going to increase the value of these tax shields. Why that's confusing to me is the way this problem's set up, everything's constant. The cash flow is constant, the amount of the debt's constant, everything's constant. So I'm not quite sure how you would do that in practice. But I think what they may be getting at with number B, but I'm very likely could be wrong here, is that you discount the cash, you value the cash flows by dividing it by 0.07, the discount rate on the debt, or actually the cost of the debt, which brings the value of the tax shields up from $98,000 to $140,000. Even with that value, this project still is not a winner, so to speak, for the company. Because it's, and you can almost see that right away, in that in order to get a 10%, since everything's fixed, nothing changes, you're getting $9,500 on $1 million investment before tax. Excuse me. You're getting a $95,000 return on $1 million investment before tax. And that goes on forever. So that's a 10% return, since this is for forever. You're getting a 10% return on this investment. I mean, a 9.5% return, and our cost of equity is 10%, or our hurdle rate, what some people would call the rate, minimum rate we'll accept, is 10%. So even before taxes, this is not giving you the 10% return. And then you take out 35% for taxes, and that makes it even worse. So it seems like usually these problems, I'm a little suspicious that I'm missing something here, because usually they set it up so maybe it doesn't have a positive value here but does there, but I'm not seeing that if that's the case. But so that's how I'd look at that problem, but my confidence level in this being accurate is pretty low. So check with the professor or someone else in your class. Okay, that's it.